mathematicians! I'm recording live from our playground at school. I know, I have my kids that are responsible for these videos, but I've been contacted recently by a lot of kids, my virtual students that I have across the country. It's so exciting. I'm trying to allow you guys to see the whole view of what we're working with here. It's so exciting to see so many friends connecting over math, and I'm so happy that many of you have been kind enough to leave some nice comments on my page and thank me for helping. And the truth is, I'm just thrilled that you guys are taking your learning into your own hands and seeking resources. My kids, of course, these videos are mandatory, lucky you, but the rest of you guys out there in virtual math land I'm impressed with how you're taking your learning into your own hands and you're seeking resources outside of your classroom. So hello and welcome. Many of you have asked, or a few of you have asked, where are we? Well, we are in Washington State. We're about half an hour out of Seattle. The mountain range that you see behind me is the Cascade. These are the Cascade Mountains, and yes, this is a view from our playground. Isn't it glorious? There was an eagle actually flying over here. I don't know if he or she is still out there, but yeah, it's springtime in the Pacific Northwest, and it couldn't be lovelier right now. Everyone is feeling happy. It's not raining anymore. I think it's like a high of 75 today. So we're getting into lesson 17. We're going to be connecting fractions with decimals, just thinking about 1 over 10. What does that mean? 1 fraction bar 10? Well, that means 1/10. It also means decimal 1. So we're connecting all of that, and then we're going to be multiplying using the standard algorithm. I'm trying to make sure you can see what we're working with. It's hard to see the beauty on camera, but trust me, it is beautiful. We are also going to be modeling on, I don't know if you saw this in 4th grade, but we're going to be modeling on 100 grid. So we're being given by Eureka 100 grids, and we're going to model the multiplication of some fractions and decimals. So let's take a look. Here we go, mathematicians. Lesson 17 is happening right now. Starting with a super simple problem. So here in A, we're looking at 1/10 times 1/10. Well, what's going on? Let's go ahead and evaluate that, and then we'll unpack the model here in a second. 1/10 times 1/10 looks like 1 times 1 up top. We multiply the numerators together. And then down low, we're looking at 10 times 10. Let's go and evaluate that. 1 times 1 is 1. Great. And then 10 times 10 is 100. Okay, sweet. 1 over 100 is equal to this in decimal form. Remember that? Remember some of you guys might get a little misty-eyed seeing this because I know you've missed it so much. Remember our place value chart? And we could put this number on our place value chart. We have 0/10ths and 1/100th. 1/100th. We can write it in fraction form or in decimal form. Also, I'd like for you guys to know, and you know this already, any fraction can be rewritten as a decimal. So 1 over 100 is equal to 1 divided by 100. Interesting, Mrs. Calamaris. So there's just so many different ways that we can play around with this. So let's just take a look at that. So 1/100th can be rewritten as 1 divided by 100, which means if we started with our 1 and we're going to divide it by 100, then the digits are going to shift to the right, because when we're dividing something, we move to the right. How many digits are we going to shift to the right when we divide something by 100? Well, 100 has 1, 2 zeros, so this one is going to shift 1, 2 place values to the right. So we've just proven in the place value chart that when you divide 1 by 100, we get 1/100th. Well, that works out perfectly because that's exactly what we got up here. So what we're doing, you guys, is all of our worlds are colliding. Place value chart, multiplication of fractions, rewriting fractions as decimals, rewriting fractions as division expressions. We've done all of these things. And just when you thought it couldn't get any better, we're also going to model it. Ah! Sorry to say, but the model, the grids, this is that 100 grid I was telling you about. We call it a 100 grid because it's 10 units wide and it's 10 units tall. So we also get to model it. The 100 grids are going to be provided for us because we are far too busy and important to spend our time and our lead drawing 100 grids. So I wanted to include this 100 grid that Eureka is giving us because I model a little bit differently. So I just want you guys to be clear. This is how Eureka models this problem. 1/10 times 1/10. This is how we would model it in my class. And I just like to model the full fractions, both fractions. And then I like to circle the intersection. Okay? Eureka's not going to do it like that, and that's totally fine. But I just want you guys to see that in the examples that were given in our text, it's going to look a little different than we do it in class, and that's totally fine. I just want you guys to know that the way I'm going to be modeling these problems, I'm going to model 1/10, yes, and then what we're doing, you guys, is we're finding 1/10 of 1/10. Another way we can play around with this is rewrite our expression as 1/10 of 1/10. 1/10 of 1/10 is finding the intersection of those two fractions. It would probably have been better for me to use the two different color method. So look at where the red intersects with that gray. The red intersects with that gray only here in that box, and that box represents 1. There's only one box. And I told you guys that this is called a 100 grid, so spoiler alert, there's 100 boxes total there. So 1/100th is equal to 0.01. So all of these amazing bits support this model, okay? So that's a very, very basic example. Now let's try to kick it up a notch. I know that I may have just blown your minds a little bit on that first example. I kind of just wanted to show you everything that we're going to do in this lesson first to really grab your attention, get you excited, but just know that we're going to be starting off very small. So here's where we're starting. Remember this old friend, our place value chart? So excited to see you back in our lives, place value chart. And I was feeling very fancy, so I used my tools to have straight lines. Are you guys so impressed? So we're going to evaluate each of these expressions, and let's just take a look at this. So we're looking at 0.1, 1/10 times 4, or 4 copies of 1/10. So let's go ahead and start with 1/10. There we are. I've modeled 1/10. Way to go, Miss C. Now we're going to make 4 copies of that. NP. These circles represent each of the tenths. So when I make 4 copies of 1/10, what do we have? We have 4/10. Sweet. Okay. You guys are on board with this? Great. What about this? 2 copies of 1/10. Well, here's 1/10, and I'm going to make 2 copies of 1/10, and done. Not my best at. So when we make 2 copies of 1/10, what we're looking at are 1 2/10. Sweet. Okay, I can handle this. Those are lines of learning, by the way. Now let's copy this. Let's evaluate this. So we have 1/100th, and we want 6 copies of 1/100th, or 1/100th times 6. Okay, let's go ahead and model that. And let's just pay close attention to our place value. This is 1/100th. So we were working in tenths, now we're hundredths. We're starting with 1/100th. And how many copies of that do we want? We want 6. No problem. 3, 4, 5, 6. Okay, cool. So when I make 6 copies of 1/100th, what do I end up with? Well, I end up with 1, 2, 3, 4, 5, 6 hundredths. Okay, I'm down to that. Oops. 6 hundredths. Did I forget my decimal point here? That is so embarrassing. Goodness sakes. That should be 2 tenths, friends. And this should be 6 hundredths. Let's take a look. Is everyone on board with that? Okay, cool. This is kind of review from what we were doing, but sometimes kids get a little skittish when they see decimals, but my kids are not afraid of decimals. They're just smaller versions of whole numbers. Okay, let's cruise through this one. So what we're looking at here, you guys, is 2 tenths times 1 tenth. We can rewrite this lovely cantaloupe color, as 2 tenths times 1 tenth. Ultimately, what we need to do here, friends, is, of course, figure out the answer and then model it. So let's determine, what is 2 tenths times 1 tenth? Up top, we're multiplying, and I've rewritten this as a fraction, and we're also going to check this out as decimal, in decimal form as well. But we've been working with a lot of fractions lately, so let's just go ahead and evaluate that in fractions. So up top, we're going to multiply the numerators together. That looks like 2 times 1. And then down low, downstairs, we're looking at 10 times 10. Multiply the denominators together, so that's 10 times 10. And then let's just evaluate this. So 2 times 1 is 2. Okay, and then 10 times 10 is 100. So 2 tenths times 1 tenth is 2 hundredths, or 2 tenths of 1 tenth is 2 hundredths. Great. So really, in lesson 17, what lesson 17 is all about, you guys, is connecting decimals and fractions. And they're just the same. I mean, this and this represent the same amount. They're just in 2 different forms. Like in Spanish, you can say sun, that's English, or you can say sol, that's Spanish. Same thing, but just 2 different forms. So let's look at this on the place value chart. So what we're looking at, you guys, is ultimately I'd like to look at this. 2 divided by 100. Or 2 over 100. 2 over 100, spoiler alert, I shouldn't have said that yet, is equal to 2 divided by 100. I would like to model 2 divided by 100 on our place value chart. So starting with 2 here in the place value, in the ones place value, sorry, if we're dividing that by 100, the numbers are moving this way. How many place values will 2 shift to the right? Well, it's going to shift to the right 1, 2 places to the right. Do you see that funny face in there? Because 100 has 2 zeros. So when we divide 2 by 100, we're going to hop 1, 2 over, and we will end there. Actually, I should put it in the same form as my original one. So when we divide 2 by 100, we are going to shift 2 to the right 2 place values, and we're going to end up with 0.02, which is 2 hundredths. Very, very interesting. So what is actually going on here, you guys, is, let's look at it in another way. Let's look at this in division form. If we are starting with 2 tenths, when we multiply 2 tenths right here, when we multiply 2 tenths by 1 tenth, what we're ultimately doing, you guys, when we're multiplying 2 tenths by 1 tenth, what we're ultimately doing is the 2 tenths is going to shift just 1 place value to the right because we're multiplying by 1 tenth. You guys know, oops, I should not have done. You guys know that 1 tenth can be written like that. So when we're multiplying 2 tenths in decimal form, 2 tenths, when we're multiplying by 1 tenth, look at what's going on here, you guys. I know this is a decimal and a fraction in the same expression, but look at what happened. What are we multiplying up top? Well, I have 0.2 times 1 in the numerators. And then what's going on down low? Well, there's only a 10. So when we're multiplying by 1/10, ultimately what's happening, you guys, is, well, what's 0.2 times 1? It's 0.2. Ultimately what's happening, you guys, is we're dividing by 10. So when we're multiplying by a decimal, by 1/10 or 100th or 1,000th, what we're ultimately doing is dividing. We're moving to the right. It's super, super cool to watch these two worlds collide. Let's go ahead and model that, and we will, and I know this is a lot, you guys, but what lesson 17 is all about is just exploring this amazing connection between decimals and fractions. Let's just continue evaluating this. 0.2 divided by 10, well, we did it right here. 0.2 or 2/10 divided by 10. This is going to hop over one place value to the right, and our final answer there is going to be 2/100ths. Let's go ahead and model this. So this is our 10 grid. There's 10 columns and there's 10 rows. So I'm going to model 2/10. Well, know that one column is 1/10. Two columns would be 1/2. Each of these columns and each of these rows are 1/10. So I can label this whole darn thing, but I'm not going to because I think you guys can see it. Just know that each row, one row is 1/10. I'm sorry, each column is 1/10, and each row is 1/10 as well. So if we were to model 2/10, I'm going to shade in 2 columns. And like I said, my modeling is a little bit different than Eureka because I'm super visual and I want it to make sense. I'm not saying Eureka is not visual, but just know my modeling is just slightly different. Okay, so that's my 2/10. I've just modeled 2 columns, or I've just shaded in 2 columns. What we're looking for here, you guys, is 1/10 of 2/10, or 2/10 of 1/10. So I've modeled my 2/10. I've shaded in 2 columns. Now what I'm going to do is model my 1/10. Well, so I've done my columns. Now I need to shade in a row. How many rows am I shading in? Well, I'm just shading in 1 row because I'm just looking for 1/10 of 2/10. So I'm going to shade in the entire row using 2 different colors. And what we're looking for, you guys, and I will label that, that's 1/10, that's 1 row. What we're looking for, you guys, is the intersection of the pink and the blue. And that intersection I'm going to circle, and I'm going to label pink and blue intersect here and here. So I'm going to write out that fraction. Numerator is 2, and I've told you guys that this grid, I didn't know I could pivot that. This grid consists of, sorry, this is crooked, 100 total squares. So the intersection of, trying to move this over, gosh, I'm using a lot of, oh my goodness, you've gone too far, Miss Sissy. Okay, the intersection of blue and pink, let's see if I can just get this, okay, is two boxes, and the denominator is 100 because that whole square grid is divided into 100 squares. Is that the same answer that we got here? Yes. Here, yes. Well, let me point out 2/100ths, you guys, we can write as 2/100ths. So time and time again, that's exactly what we got here and here. So we are really, again, just working on connecting this decimal world and this fraction world and supporting all of that magnificent work in a model. Let's take a look at some more here, guys. Okay, so now we're looking at 1.2 times 0.1, or 1 2/10 times 1/10. I'm going to, let's check this out in the place value chart. So we just identified, or I just showed you guys, that 1.2 times 1/10 can also look like this, right? 1/10 in fraction form, 1/10 in decimal form. So 1.2 times 1/10, show that on the place value chart, is equal to, well, what do we have upstairs? We have 1.2 times 1, and then our denominator is 10. Let's evaluate that. So we have 1.2 times 1 is 1.2. What we're looking at here, you guys, is 1.2 over 10, or 1.2 divided by 10. Again, when we're multiplying by 1/10, ultimately what we're doing once we start evaluating, you guys, is dividing by 10. So 1.2 divided by 10, what does that mean? That means that 1.2 is going to shift to the right, because you guys know 1.2 over 10 can be written as, any fraction can be rewritten as a division expression. So 1.2 over 10 is equal to 1.2 divided by 10. So if we need to look at 1.2 divided by 10, we know that 1.2, each of the digits is going to shift to the right. How many places? One place, because 10 has 1 0. So let's go ahead and take 2 and shift it over to the right, 1 place value. And let's take our 1 and shift it over to the right, 1 place value. This is exactly what we worked on in Module 1 for a long, long, long time, so that we have a very solid foundation of what happens to digits when we divide by 10, powers of 10 I should say, or multiply by powers of 10. So here, when we divided 1.2 by 10, we have 0.12, or 12 hundredths. Well, there's the answer, 12 hundredths. Let's model that, shall we? 1.2, we're looking for 1.2 of 1/10, or 1/10 of 1.2. Why do we have 2 base 10 grids though? Well, we have 2 base 10 grids, or not base 10 grids, 200 grids, because 1.2 is 1 full, these grids represent 1 whole, plus some. So what we need to do, we're going to model 1.2 times 0.1. You guys have seen in this problem and in previous problems that when we're multiplying by a decimal, ultimately what we're doing, you guys, is dividing. When we're multiplying by 0.1, ultimately what we're doing is dividing by 10. If we are multiplying by 100th, what we would be doing is dividing by 100. And I know that is a lot to wrap your mind around, but I just want to model that to you, for you. 1.2 is equal to 1 whole plus 2 more columns. And it's really nice that these grids, these 100 grids, are given for us, because otherwise it would take a long time to set up the grid and then do the modeling. Okay, so what I've just modeled here for you guys is 1.2. And let me get rid of those arrows because I want to, oh my gosh, giant eraser. Wow, that is a large eraser. Let's model, I want my entire 1.2 to be labeled, not just the individual pieces. Okay, so I hope you guys can feel good about the fact that 1.2 is modeled in pink. It's that whole one plus 2 columns. 1 whole is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So that's our 1 whole, and then I needed 2 more columns. Ultimately, what we're looking at here, you guys, is 12 columns. I have 10 here and 2 here. So we're multiplying 1.2 times 0.1 times 1/10, which, so we've shaded in 12 columns. Now we need to shade in just one row. We're looking for 1/10. 1 row represents 1/10 because there are 10 rows. So our denominator is 10, and I'm just shading in one of those rows. So the numerator will be 1. So I'm going to shade in, again, the entire row, but I have to shade in the entire row, and I'm choosing to shade in the entire row on both of our 100 grids because 1.2 needs 200 grids to be modeled on because it's larger than 1, right? It's 1.2. And what we're looking for here, you guys, when we're looking for our intersection of 1/10 and 1.2, we're looking at where the pink and the green collide. So I see 2 boxes here, and then I see 10 boxes here. So in order to find 1.2 times 0.1, we're looking for the green and the pink intersection. And I'm going to circle that, and we're going to consider what fraction is that. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, that's where the pink and the green are colliding. 12 boxes with pink and green over what is one of our grids divided into? 100. Our denominator is 100, not 200. Denominator is what is our whole divided into? And our whole is divided into 100. So our question is 12 hundredths? Is that, oh, I accidentally erased that. Is that the answer? I didn't even notice my giant eraser deleted that. Is that the answer that we got up here when we when we divided 1.2 by 10? Well, yeah. 2 hopped over 1 place value, 1 hopped over 1 place value. 12 over 100, you guys, is equal to 12 hundredths. So what we've shown is that we've supported our work, our evaluation here with our modeling. So it's exciting. I love it.